Hello everyone, welcome back to my channel Tech Guides. I am Yusuf bin Aslam, your instructor at TGs. Let's start with today's video. What is a network? A collection of servers, computers, mainframes, network devices or other devices that can allow data sharing among them. The biggest example of a network is Internet, where millions of people are connected around the world. Let's move on to the next topic, type of networks. When we say type of networks, we are referring to different network topologies. These are bus, star, ring, mesh, and tree. It is also known as line topology. In this kind of a setup, all the network devices and terminals are connected through a single trunk or a backbone. The connectivity interface can be either RJ45 or Quixl. In this kind of a topology, the major drawback is if one of the terminals goes down, the whole network goes down. It is a most commonly used architecture. It is centrally managed. It either uses a hub or a switch. All the nodes connect directly to them. If one node fails, still the network is functional. Now let's discuss the difference between a switch and a hub. A switch is an intelligent device which broadcasts the first time when it is turned up. It sends a hello packet to the entire network, learning back the IP addresses and building a table. Now in case of a hub is a non-intelligent device which broadcasts a data packet, and the network tends to be quite slow because every time a data packet is received by the hub, it will be broadcasted to the entire network unless the receiving terminal receives a packet. The next kind of architecture we will talk about is a ring topology. In this kind of a setup, all nodes are connected to each other in a circular path. Each node connects to two other nodes just like points on a circle. This is known as ring topology. Now, in ring topology, data packets move in a circular motion, which is usually known as unidirectional. But some of the ring topologies allow data packets to travel the other way around, which is also known as bidirectional. The next topology we will talk about is a mesh topology. In this kind of a setup, maximum number of connections are allowed for a computer or any other network device. A mesh topology is more suitable for a wireless network. In a fully mesh environment, each computer is connected to each of the other computers. In order to calculate the number of connections, the formula is flashed on the screen, where n is the number of computers. Whereas in a partially meshed network, two of the computers have connections to each other. It is an inexpensive way to implement redundancy. But at the same time, if one of the primary computers fails, the network is still operational. The last topology we will talk about is a tree architecture. A tree is comprised of star and bus networks, which are combined together. The bus acts as a backbone or a trunk for all the star networks, whereas a star acts as a branch. Just in case if the backbone breaks at any point, the whole network will go down. But in case of star network, they will still remain functional. Let's talk about the advantages and disadvantages of bus topology. I will start with the advantages. It works very well and it is more suitable for a small network. It is the easiest topology for connecting computers and or peripherals in a linear fashion. And on top of it, less cable length is required than a star topology. Now let's move on to the disadvantages. It is very difficult to identify the problem in case of a network goes down. Secondly, it is hard to troubleshoot individual computer issues. Third, it is not advised for a large network. Now we need terminators which are required at both ends of the backbone cable. If we don't add terminators, then definitely data packets will be lost. And adding on more devices will definitely slow down a bus network. And if in case the main cable is damaged, the network will fail. Let's begin with the advantages and disadvantages of a star topology. First, let's start with the advantages. This kind of a network is centrally managed through a use of a hub, switch, or a router. It is very easy to add another computer to the same network by just plugging in the network cable to the hub, switch, or a router. In case if one computer on the network fails, it will not impact the network at all. Rather, the rest of the network continues to function normally. Let's talk about the disadvantages. It may have a higher cost to implement, especially when using a switch or a router as a central network device. The central network device determines the performance and number of nodes the network can handle. If the central computer, hub, switch, or router fails, the entire network goes down and all computers are disconnected from the network. Let's talk about the advantages and disadvantages of a ring topology. First, advantages. Data normally flows in one direction, which eventually reduces the chance of packet collisions. A ring topology does not need a server-controlled network connectivity between each workstation. Data can be transferred between workstations at high speeds. Additional workstations can always be added without impacting the performance of the network. Now, the disadvantages. All data being transferred over the network must pass through each workstation on the network, which will definitely slow it down as compared to a star topology. The entire network will be impacted if one workstation shuts down. The hardware needed to connect each workstation to the network is more expensive than Ethernet cards. Let's talk about the advantages and disadvantages of a mesh topology. First, the advantages. It manages very high amounts of traffic because multiple devices are transmitting data simultaneously. In case if a device fails, it won't cause any breakdown in the network and transmission of data. Adding in multiple devices will not disrupt data transmission between any of the other devices. Now, the disadvantages. The cost involved to implement is higher than the other network topologies, hence it makes it a less desirable option. Building and maintaining this topology is always difficult and time consuming. Redundant connections are very high, which adds to more high costs and also potential for reduced efficiency. Let's talk about the advantages and disadvantages of a tree topology. First, the advantages. This topology is a combination of bus and star. This topology provides a central data arrangement of the nodes. The leaf nodes can add one or more nodes in the chain, as the topology provides high scalability. The other nodes in a network are not affected if one of their nodes gets damaged or it is not working. Now, the disadvantages. This kind of a network is very difficult to configure as compared to the other network topologies. The length of a segment is limited, and limit of the segment depends on the type of cabling which is used. Due to the presence of large number of nodes, the network performance of tree topology will definitely become slow. If the computer in first level is erroneous, next level computer will also go under problems. And it requires large number of cables compared to star and ring topology. Let's move on to the next question. How many types of cables are used in a network? There are 4 types of cables which are used: Quixl, shielded twisted pair, unshielded twisted pair, and fiber optic cables. Let's discuss in a short brief what are these cables. The first type of cable we will talk about is a Quixl cable. A Quixl cable is comprised of a single thin copper conductor which is encapsulated with a plastic, and on top of it there is a braided metal shield. The braided metal shield is responsible to stop any kind of obstruction from fluorescent bulbs, motors, or other computers. The next type of cable I am going to talk about is a shielded twisted pair, which is also known as STP. It is more expensive than an unshielded twisted pair, which is known as UTP. It carries an impedance of 150 ohms and can be run till the length of 90 meters. Shielded twisted pair are used in networking environments where there is a high level of obstruction and crosstalk, such as air conditioners, power lines, and other noisy equipment, etc. etc. The next cable we are going to talk about is unshielded twisted pair. A UTP cable carries an impedance of 100 ohms. This cable is smaller in diameter and is not protected. Why? Because it does not come with a metal shield, and it makes it more prone to EMI. The only advantage of a UTP cable is that each pair is twisted to avoid crosstalk. The next type of cables we are going to talk about are fiber optic cables. A fiber optic cable consists of a glass core which is surrounded by different protective materials. Fiber optic cables avoid electrical obstructions by transmitting light instead of electrical signals. Moving on, let's get started to know the basic protocols used in a network. Now, before we talk about the different protocols used in a network, let's first learn what is a network protocol. An established set of rules that determines how data will be transmitted between network devices or a computer is known as a network protocol. Let's have a brief overview of all the protocols that we have just discussed right now. The first is Transmission Control Protocol. TCP is a popular communication protocol which is used for communicating over a network. It divides any message into a series of packets that are sent from source to destination, and there it gets reassembled at the destination. Internet Protocol IP is designed explicitly as addressing protocol. It is mostly used with TCP. The IP addresses in packets help in routing them through different nodes in a network until it reaches the destination system. User Datagram Protocol, or UDP, is a substitute communication protocol to Transmission Control Protocol (TCP), implemented primarily for creating loss tolerating and low latency linking between different applications. Post Office Protocol (POP), or we can name it as POP3, is designed for receiving incoming emails. SMTP, Simple Mail Transfer Protocol, is designed to send and distribute outgoing email. File Transfer Protocol (FTP) allows users to transfer files from one machine to another. Types of files may include program files, multimedia, text, documents, and much more. HTTP is designed for transferring a hypertext between multiple systems. HTML tags are defined for creating links. These links may be in any form. This protocol is designed on a client-server principle, where a connection is established to the server for plotting a request. Once the server acknowledges a request initiated by the client, it responds accordingly. HTTPS is abbreviated as Hypertext Transfer Protocol Secure. It is a standard protocol to secure the communication among two computers. The biggest example is online banking. With this, we have reached the end of today's video. As we all know, learning never stops. irrespective of age and the field you come from. I hope today's topic would have been delivered with useful information. If you have really liked my content and the video, do share your feedback in the comment section below. And yes, like, share, subscribe, and don't forget to hit the bell icon to stay updated of all the upcoming ones. Till then, take care, stay safe, signing off.